Hi there. As announced, here's my review about formal charge calculations. The question is, why formal charge calculation at all? It is a strong aid when deciding the right one among possible Lewis structures. The two preconditions which are generally observed are electronegativity is not considered here and complete electron sharing in the compound is assumed. Formal charge calculations are done with this equation, where Fc equals V, the number of valence electrons on the atom, minus N, the number of non-bonding valence electrons on the atom, minus B, the number of bonding electrons, which we have to divide by 2. This equation enables you to calculate formal charge for each atom in any compound, and finally decide to choose the structure in which all the atoms of possible structures have the lowest value, as close to 0 as possible. One important hint: if formal charges for two structures are alike and both observe the octet rule, you will have to take the one with the lesser bonds. Let me show you a few examples. Here the carbonate ion, the Lewis structure of which is like this. I balance the two negative charges by sodium ions. Formal charge calculation gives, for carbon, 4 valence electrons minus 0 non-bonding minus 8 bonding electrons divided by 2 gives a formal charge of 0. For the single bonded oxygens we have 6 valence electrons, 6 non-bonding electrons and 2 bonding electrons divided by 2 gives a formal charge of minus 1, which is completely okay since these oxygens bear a negative charge each. The double-bonded oxygen has 6 valence electrons, 4 non-bonding electrons, and 4 bonding electrons divided by 2 give a formal charge of 0. We probably can't get closer to 0 with the formal charges, so the proposed structure is okay, not regarding resonance, which I will treat in another clip. My next example is taken from the tutorial where I discussed exceptions from the octet rule, BF3 boron trifluoride. One proposed structure obviously satisfying the octet rule is this, but there's an inconvenience. If you calculate formal charges, we see that boron has a negative formal charge and double-bonded fluorine one of +1, which is very appalling since fluorine is the most electronegative element in the PSE. If we consider this structure, however, formal charges are 0. The fluorine atoms feature octets, and although boron remains electron deficient with only 6 electrons, this is the correct structure. If we draw the Lewis structure for sulfur trioxide, we start like this. Realizing that sulfur is electron deficient, we can arrange the molecule in this way, pulling an electron pair from oxygen in between oxygen and sulfur, thus creating a double bond. The proposed structure looks then like this, satisfying the octet rule. Calculating formal charges gives for sulfur 6 valence electrons minus 0 non-bonding minus 8 bonding electrons gives a formal charge of +2. For the single bonded oxygens we have a formal charge of -1. And for the double bonded oxygens we arrive at a formal charge of 0. The non-zero charges on single-bonded oxygen and sulfur give a strong indication that there may be a better solution for the sulfur trioxide structure. In fact, if we continue to rearrange electrons in this way, pulling electron pairs from the oxygens in between oxygen and sulfur, we obtain this structure, where all the oxygens are double-bonded and sulfur is hypervalent with 12 electrons, which is okay since it is a third period element. Formal charge calculation gives 0 for sulfur and 0 for oxygen. So this is the correct structure. In this slide, I want you to play around with the 3 elements carbon, nitrogen, and hydrogen, how to combine them to a meaningful structure. Let's put our knowledge about how to draw Lewis structures apart for the moment and consider these structures. They all contain 10 valence electrons. For your own sake, stop the video and try to calculate formal charges for the structures. Then we will check it together. The formal charge for the first structure is for carbon +1, For nitrogen, -1, and for hydrogen, 0. For the second structure, we obtain 0 formal charges throughout. The third structure reveals for carbon 1 positive charge, nitrogen 1 negative charge, and hydrogen 0 again. For the last structure, we obtain 0 formal charges for all the atoms again. We see that structures 2 and 4 feature formal charges of 0 for all atoms, so they could both be okay. Latest here, we should remember the octet rule and choose structure 4 as the correct one, which is hydrogen cyanide. This slide sums up what you have to consider when calculating formal charges. Thanks for watching. Good luck in your exam. See you again.